Shape layers get to have rounded corners, so why don't masks? Today we're fixing Adobe's oversight using an expression turned into a preset. About 6 years ago, I shared a method to alter the rounded corner of a rectangle mask, and it remains one of my most popular videos. Yay me! But the method I shared is time consuming. You have to do each corner individually, and in most use cases, you could probably use a shape layer as a track mat. But there are still times when you have to use a mask. But managing Bezier handles is awkward. So I did a little digging and learned about the Kappa constant. First studied by Gerard van Gusthoven in 1662, Kappa is a magic shortcut number, which can be used to create curves using straight lines and control handles. Sounds a bit like the convert vertex tool. There is some complex looking code involved, but if you don't want to follow along, there's a link in the description to both a text guide containing the code and a script. To use, draw a mask on your image or solid, and with it selected, go to File, Scripts, Run Script File, and then load in Add Rounded Corners to Mask from wherever you have saved it. When it runs, it will add the expression to your mask and add a slider. Adjusting the slider's value will adjust the curve. If you have multiple masks, you just select the mask or masks before running the script. If you want to disable the expression, on the mask path property, click on the equals sign which turns it off. Okay, that's what it does. Here's how it works. So originally I wrote out the entire code in script form, talking you through every bracket, brace and semicolon. But I'm not convinced any of us learn complex code that way. So I'm going to try something new. Go grab the code in the text guide from Coffee. It's down as pay what you want, but that means it's free. Then for the rest of this video, I'm going to talk you through the blocks of code. I'm hoping that's a better use of your time and mine. Let me know in the comments what you think. So first, we define the original path. OrigPoints makes a copy of the existing mask path, and isClosed records if the mask is open or closed. If the mask is open, then this affects the first and end points. NumPoints counts the number of points, and we'll use that to iterate through. Then a check to see if there's more than one point in the mask. If there isn't, there's not much point in continuing, and the else at the bottom of the code says just use what's there. Next, we set out our variables. R for the roundness slider, Kappa of course, and let's also calculate a constant for tangent length, roundness times Kappa. Then we need some arrays. These will be used in the createPaths function at the end of the code to create a replacement mask. So we need the new points as well as adding a point before and after the placement of the originals. And each point comes with an incoming tangent and an outgoing one. Then we get a helper function to calculate the vector lengths. When we feed it the value of v, which we'll create later, it returns the length the vector should be. Now we loop through each of the existing points on the mask, using NumPoints to end the iteration. In order to calculate the vector, we need to know the values of the previous and next mask points. And if the mask path is closed, at the start of the mask, the previous point is the last one, and at the last point, we need the first point to be the next one. I'm rating this before I make the animation to explain it. I really hope that that is helping. And if the path is not closed, we set the first and end points as not needing their previous or next, because they have nothing to curve to. Next, rather than keep writing square brackets I, let's make 3 variables to hold those values. Remember, we're inside an iterative loop here, so this happens for each point. So now we move on to calculating the vectors. We do this by creating arrays to hold the coordinates for the distance between the previous, current and next points. Then we use our helper function veclen to convert these arrays into variables for the lengths for the previous and next points. And if they are 0, then add the current point with no tangents. Then we need to normalize the vectors, turning them into direction indicators. Taking the horizontal value of the previous vector and dividing it by the distance between the previous point and the current point, then doing the same for the vertical value. and then repeating for the next vector. Next, let's clamp the curves we're making to ensure that whatever roundness is set does not mean we get a loop in the curve if 2 points are too close to each other. We can do that simply by using mathmin, which picks the lowest value. And once we have our radius, multiply it by kappa for the perfect length for the tangent. Now we need to create our 2 points, which flank the original. And current rad here is setting their distance from the original point. Now we need to add our new points, PA and PB, to the new points array, along with their in and out tangents. PA's in tangent is 0, as this is going into our corner curve. It's nothing to do with the previous point in the mask. Likewise, PB's out tangent is 0 for a similar reason. Wait, likewise means the same thing, so I didn't need to say that last bit. I know code, not how to speak English good. But we're now out of the loop. So now, having all the new points in our array and tangent arrays, we can use them in createPaths. And make sure to include the closing else statement, but we're done. Now you can save the mask and roundness slider as an animation preset, but when you apply it, it will overwrite whatever mask you have with the copy of the one saved. This will work okay, but then you have to copy the mask's expression to a new mask. So instead, here's a script that does the same thing. It adds the slider control, and adds all the code from the expression to the first mask on your layer. If you're stuck, remember there's a preset and text guide linked in the description. And let me know in the comments if this format works for you. It feels more intuitive compared to dictating the code then trying to explain it as I go. Until next time though, happy rounding.